Yes, Aditi. Unmute yourself and then talk. Yes, Aditi.
मैम एटॉमिक रेडियस का देखा था।
हाँ, हमने रुदरफोर्ड का एटॉमिक मॉडल देखा था और देखा था उसने क्या कैसे दिया एटॉमिक मॉडल। उसने बोला कि एक छोटा सा न्यूक्लियस है और न्यूक्लियस के इर्द गिर्द बहुत सी खाली जगह है जिसमें कि इलेक्ट्रॉन रिवॉल्व हो रहे हैं। राइट। आप लोगों को मैं एक वीडियो दिखा देती हूँ ताकि आपको वो पता चले कि क्या है एक्चुअली व्हाट इज द रदरफोर्ड्स एटॉमिक मॉडल। ओके, नाउ चिल्ड्रन लिसन सी हियर। एवरीबॉडी कैन एबल टू सी माय स्क्रीन। सबको स्क्रीन दिखाई दे रही है मेरी? मेरी
यस
आवाज आ रही है क्लियर?
यस मैम।
ओके, we will start and pay attention towards this video. Mute yourselves.
Atomic model was quite commendable when it came to explaining the structure of atoms. However, it was not very appropriate theoretically. And why are we saying so? We know that any charged object which revolves in a circular motion gains acceleration gradually. Similarly, if the electron is moving fast in a circular path, then it will also gain acceleration. And on gaining acceleration, it's bound to liberate energy in some form. Now, if it continuously keeps radiating energy, then ultimately all the energy of the electron will get over and it will fall into the nucleus. This would result in high instability of the atom. But wait a second, all these things do not happen in an atom. And how do we know this? Because in nature, all the atoms are stable. That means the hypothesis put forth by Rutherford was also incorrect? Not really. The hypothesis just needed slight modifications. These were made by the next legendary scientist in our list called Niels Bohr. He made a few additional explanations to describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy. Now, these points definitely tell us why an atom is so stable. But what exactly are these paths or orbits in which the electrons revolve around the nucleus? Let's understand with an example. Do you know how our solar system is? Yes, it appears somewhat like this. Now here, the sun is stationary at the center while the planets revolve around it. But have you noticed that the planets always revolve in fixed paths? We never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center, and the electrons are like planets which revolve in fixed, defined orbitals. These electron orbitals are referred to as shells or energy levels. Now, the name energy levels gets us to an important concept. Niels Bohr suggested that the electrons revolving in these orbitals do not radiate energy. This is justified when we use the term energy levels, because it indicates that each shell has got a defined energy level. That means when the electrons revolve in these shells, they do not liberate any form of energy. And how do we name these shells to indicate their position? It's simple. Beginning from the one near the nucleus, we name them as the K shell, L shell, M shell, N shell, and so on. Yes, K, L, M, N, and so on. And what if we want to number them? In that case, we use the letter N in lowercase and write them as N equals 1, N equals 2, N equals 3,
Yes,
and
beta.
so on.
Itu suruh again.
So we can name
Yes.
them alphabetically or we can...
क्या हुआ? Yes, children. What happened? Yes, children. What happened?
No, ma'am.
Then who has been called to me? Are you understanding what is going on here? See, we have discussed regarding the Rutherford's model of atom. Rutherford model, according to the Rutherford model of atom, I told you
Gain
that,
acceleration gradually.
see here,
If the electron is moving
what happens?
fast in a circular path, then it will also gain acceleration.
Now I will
And
tell
on
you that
gaining
what is
acceleration,
going to be happen.
Bound to liberate energy in some form. Now, if it continuously keeps radiating energy, then ultimately
Now see, according to the Rutherford model of atom, he has told that the electron is revolving around the nucleus in such kind of the circular path. And as I told you that electrons are the charged bodies. Whenever these electrons are revolving in the circular path, then at that time they are radiating the energy, means they are trying to lose the energy. What will happen whenever the electron is losing the energy? These electrons slowly comes together towards the nucleus, and the electron will settle down on the nucleus. Automatically what will happen? The stability or the structure of atom will not remain stable. The structure of atom will be get collapsed. But you know that the structure of atom is very stable, because the objects those are around us, they are not changing their shape and size according to themselves, right? If suppose the atoms will not be stable, how the objects will remain in the stable shape? They will be changing their shape every time without change in the temperature and pressure. And therefore here the Rutherford's model, it is to be get discarded, because he failed to explain the stability of the atom. Have you understand this one, children?
Yes,
मैंने
ma'am.
जो कुछ बोला अभी आपके समझ में आया? मैं नोट्स दूंगी आपको बाद में, पहले समझ के। Have you followed this one? हाँ, समझ में आया?
Yes, ma'am.
and that is only get explained in this video. That is only to be get explained in this video. Listen carefully. And it will fall into the nucleus. This could result in high instability of the atom. Wait a second. All these things do not happen in an atom. And how do we know this? Because in nature, all the atoms are stable. That means the hypothesis put forth by Rutherford was also incorrect? Not really. The hypothesis just needed slight modification. These were made by the next legendary scientist in our list, called Niels Bohr. He made a
Now see, this Niels Bohr, who is a student of the Rutherford, has been explained has been re-explained the hypothesis of the Rutherford. According to him, he has considered that he has made some postulate or he has made some assumptions for explaining the stability of the atom. What kind of the assumptions does he
detailed
make?
explanation
Listen
to
carefully.
describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy.
Now see, these are the postulate of the Bohr's Niels Bohr. Now he has told that only certain special orbits called discrete orbits of electrons are allowed inside the atom. यानी कि उसने क्या किया कि सारे इलेक्ट्रॉन एक ही सर्कुलर पाथ में नहीं घूम रहे. Electrons are revolving in the different circular path. There are the number of orbits are present around the nucleus, and these orbits are having the discrete energy. Now what is meant by the discrete energy? You must have to understand what is meant by the discrete energy. देखो, आप बाजार में जाते हो या नहीं, आप कहीं फर्स्ट फ्लोर तक आपको आना है, आपको स्टेयरकेस पता है, राइट? डू यू नो द स्टेयरकेस?
Yes,
डू
ma'am.
यू नो स्टेयरकेस, राइट? अब स्टेयरकेस में क्या होता है? हर एक स्टेयर जो होती है वो एक डेफिनेट लेवल से या डेफिनेट डिस्टेंस से एक दूसरे से सेपरेट होती है ना, राइट? विल डिस्कस दिस, just a minute. I'm going to start with this also, but later one. First of all, I would like to explain that what is meant by the discrete orbitals. मैं आपको थोड़ा सा डिस्क्रीट ऑर्बिटल के बारे में बता दूं। अब देखो डिस्क्रीट ऑर्बिटल है क्या, मैं थोड़ा सा ये डायग्राम निकालती हूँ। ये देखो, आई एम गोइंग टू ड्रॉ द डायग्राम। बेटा प्लीज म्यूट योर सेल्फ। क्या होता है ना, आप लोग म्यूट नहीं करते हो तो बाकी के क्लास के सारे लोगों को डिस्टर्ब होता है ना, आपको भी डिस्टर्ब होता होगा। जब मुझसे बात करनी है तभी आप खुद को अनम्यूट करो, नहीं तो म्यूट रखो खुद को। नाउ सी, आई एम गोइंग टू डिस्कस अबाउट दिस काइंड ऑफ द थिंग्स। नाउ सी हियर, आई एम गोइंग टू ड्रॉ सम डायग्राम हियर। आई एम गोइंग टू सिलेक्ट द pencil and I'm going to draw some lines. See here, this is the first one line, first one staircase. This will be second one staircase, third one staircase, third, fourth, fifth, sixth. ये ऐसे staircase है। हाँ, मैंने staircase अच्छे से ड्रॉ नहीं किए है क्योंकि मैं कोई ड्राइंग टीचर तो हूं नहीं, लेकिन मैंने कोशिश की है। अब आप कंपेयर करो। अब ये जो स्टेयरकेस है, ये समझो फर्स्ट स्टेयरकेस है, ये सेकंड है, ये थर्ड है, ये फोर्थ है और ये फिफ्थ है। इन दोनों स्टेयरकेस में एक डेफिनेट डिस्टेंस है, समझो 1/2 मीटर का डिस्टेंस है इन दोनों स्टेयरकेसेस में, राइट? एक दोनों स्टेयरकेस एक दूसरे से 1/2 मीटर से दूर है, राइट? दे आर सेपरेटेड बाय द 1/2 मीटर डिस्टेंस। अब देखो, आप जब फर्स्ट स्टेयरकेस से सेकंड स्टेयरकेस पे जाते हो तो आपने कितना डिस्टेंस तय किया है? हाउ मच डिस्टेंस यू हैव कवर?
half.
हाफ। वेरी गुड। अगर आप सेकंड स्टेयरकेस से, यहाँ तक आपने हाफ डिस्टेंस कवर किया। अगर आप सेकंड से थर्ड तक, थर्ड से फोर्थ तक और फोर्थ से फिफ्थ तक जाते हो तो कितना डिस्टेंस कवर किया आपने? बोलो, हाउ मच डिस्टेंस यू हैव कवर्ड? 5 स्टेयरकेस। कितना किया?
2.5. 2.5.
Very good. 2.5. Everybody has been answered in that way, right? Why you are able to give me such kind of the answer? Because you know the separation between the two stair is the fixed. Have you followed this one? Separation between the two staircase, it is the fixed one. And now consider that these staircases are nothing but the different type of the energy levels. These are nothing but the energy levels. जैसे कि ये पहली एनर्जी लेवल है, ये दूसरी एनर्जी लेवल है, ये तीसरी एनर्जी लेवल है, ये चौथी एनर्जी लेवल है और ये हो गई, दिस इज नथिंग बट द फिफ्थ एनर्जी लेवल। आप जैसे स्टेयरकेस में का डिफरेंस फिक्स है, उसी तरह से इन एनर्जी लेवल में का जो डिफरेंस है, दिस डिफरेंस इट इज आल्सो द फिक्स्ड वन। और कितना है इसका डिफरेंस? इसका डिफरेंस है h इंटू न्यू। कितना है डिफरेंस इसका? h इंटू न्यू। हर एक एनर्जी लेवल में एक डेफिनेट अमाउंट ऑफ एनर्जी है, ना कम ना ज्यादा। पहले में एक h न्यू एनर्जी है, दूसरे में 2h न्यू एनर्जी है, तीसरे में 3h न्यू एनर्जी है, चौथे में 4h न्यू एनर्जी है। यानी कि उन दोनों में का डिफरेंस कैसे है? फिक्स है। कितना है? h न्यू। डिस्क्रीट का मतलब होता है फिक्स्ड, डेफिनेट। हैव फॉलोड दिस वन? डिस्क्रीट का मतलब होता है फिक्स या डेफिनेट। मैं और एक एग्जांपल बताती हूँ आपको। आप लोग पोटैटो चिप्स या कुरकुरे के पैकेट्स लेते हो मार्केट में से, राइट? कैसे वो अलग अलग पैकेट्स होते हैं ना, छोटा पैकेट होता है, थोड़ा सा मीडियम साइज का पैकेट होता है, थोड़ा सा बड़ा पैकेट होता है, फिर से और थोड़ा बड़ा पैकेट होता है, फैमिली पैक भी होता है, राइट? देखो फैमिली पैक में कितने सारे चिप्स होंगे, समझो 1 kg चिप्स होंगे। आप छोटा पैकेट खरीदने जाते हो तो उसमें कितने चिप्स होंगे, मैक्स 20 ग्राम चिप्स होंगे, राइट। 10 रुपए में वो 20 ग्राम चिप्स आपको देगा, 20 भी नहीं देता, वो 10 ही ग्राम देता है चिप्स, राइट। अगर आपको 10 रुपए में 10 ग्राम चिप्स का पैकेट मिल रहा है, लेकिन आपको कितना लेना है, 12 ग्राम के चिप्स लेने हैं, तो आप पैकेट में से खरीद सकते हो क्या? यस चिल्ड्रन, आप पैकेट में से 12 ग्राम के चिप्स खरीद सकते हो क्या?
नो।
नहीं, नहीं। क्यों? क्योंकि चिप्स की क्वांटिटी हर एक पैकेट में फिक्स्ड है, राइट। हर एक पैकेट में फिक्स्ड क्वांटिटी है। लेकिन समझो आपको 100 ग्राम चिप्स खरीदने हैं, तो आप पैकेट में से ले सकते हो ना? ले सकते हो, नहीं ले सकते हो?
यस मैम।
कितने पैकेट्स लोगे रे? 100 ग्राम चिप्स लेने हैं आपको, तो कितने पैकेट्स लोगे आप? 10। वेरी गुड, राइट। क्यों? क्योंकि ये कैसे कैलकुलेट किया, क्योंकि आपको पैकेट में की फिक्स्ड अमाउंट पता है, राइट। उसी तरह से एटम में जो सर्कुलर पार्ट्स है या सर्कुलर ऑर्बिट्स है, वो सर्कुलर पार्ट या उस सर्कुलर ऑर्बिट्स में क्या है, सी हियर, सपोज आई एम गोइंग टू ड्रॉ दिस इज द फर्स्ट वन सर्कुलर, दिस इज द न्यूक्लियस, अराउंड इट the second one circular orbit it is to be there. Suppose I'm going to draw the second one circular orbit like this one. Just a minute, I'm going to resize this orbit. ये सेकंड सर्कुलर ऑर्बिट हो गया, राइट। ये सेकंड सर्कुलर ऑर्बिट हो गया। अगर मैंने थर्ड सर्कुलर ऑर्बिट लिया तो क्या हो जाएगा, दिस इज द, ये सेकंड सर्कुलर ऑर्बिट हुआ। पहला वाला न्यूक्लियस लिया हमने, राइट। पहला वाला क्या लिया हमने, न्यूक्लियस। ये बीच में का जो है, इट इज नथिंग बट द न्यूक्लियस। समझ में आ रहा है? दिस फर्स्ट वन इट इज द पॉजिटिवली चार्ज न्यूक्लियस। ये पॉजिटिवली चार्ज न्यूक्लियस है। इसके इर्द गिर्द ये फर्स्ट सर्कुलर ऑर्बिट है, ये दूसरा सर्कुलर ऑर्बिट है। इन दोनों में का जो डिफरेंस है ना, दिस डिफरेंस इट इज द कांस्टेंट, राइट। फर्स्ट से दूसरे तक का डिफरेंस कितना है, एच न्यू, क्योंकि इनमें एक डेफिनेट अमाउंट ऑफ एनर्जी है और इसीलिए इनको बोलते हैं डिस्क्रीट ऑर्बिट्स। समझ में आया क्या? आई फॉलोड व्हाट इज मीन बाय द डिस्क्रीट ऑर्बिट चिल्ड्रन?
यस मैम।
हाँ, डिस्क्रीट यानी कि डेफिनेट, दे आर हैविंग ए डेफिनेट अमाउंट ऑफ द एनर्जी विद इन देम, एंड सो इट इज कॉल्ड एज ए डिस्क्रीट ऑर्बिट वन, राइट। इट इज कॉल्ड एज ए डिस्क्रीट ऑर्बिट। Discrete means the same. Now see what is meant by the discrete orbits. Discrete means the orbits having definite amount of energy, right? इसका ये मतलब होता है। समझ में आया? अब देखो बोर का दूसरा पोस्टुलेट क्या है, right? Now see what is the second postulate. While revolving in this discrete orbit, the electrons do not radiate the energy. क्या कर रहा है? While revolving in
Now,
this
these
orbit,
points definitely tell us why an atom is.
while revolving in this discrete orbit, electrons do not radiate the energy. इस डेफिनेट अमाउंट ऑफ एनर्जी के ऑर्बिट में जब इलेक्ट्रॉन रिवॉल्व होता है तो वो एनर्जी रेडिएट नहीं करता है, राइट। वो एनर्जी रेडिएट नहीं करता है। एक्चुअली बोर ने किसके साथ कंपेयर किया? इट इज ही हैज कंपेयर्ड विद दैट ऑफ द सोलर सिस्टम, आवर सोलर सिस्टम। अब देखो कैसे कंपेयर किया है।
But what exactly are
Watch
these
it carefully.
or orbits in which the electrons revolve around the nucleus? Let's understand with an example. Do you know how our solar system is? Yes, it appears somewhat like this. Now here, the sun is stationary at the center while the planets revolve around it. But have you noticed that the planets always revolve in fixed paths? We never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center. Know how our solar system is somewhat like this. Now here, the sun is stationary at the center.
Now see how he has compared with the solar system. This sun, it is the stationary at the center of the solar system, and the planets are revolving in a definite path, right? These paths are to be known as a discrete path. These are nothing but the discrete energy level, or the discrete paths are these one. And whenever you know that हमारी जो अर्थ है वो सन के इर्द गिर्द एक डेफिनेट पाथ में घूम रही है, ऐसा होता है क्या? अर्थ अचानक से सन के पास चली गई, या सन अचानक से अर्थ के पास में आ गया, या अर्थ के बाद जो छोटा प्लैनेट है वो समझो अर्थ के पास में मार्स आ गया, मार्स के पास में अर्थ चली गई, ऐसे होता है क्या? यस चिल्ड्रन, इट इज
No, ma'am.
नो, इट इज
No,
नॉट
ma'am.
हैपन।
No, ma'am.
ऐसा क्यों नहीं होता है? क्योंकि वो एक डेफिनेट पाथ में ही रिवॉल्व करते हैं, वो अपना पाथ चेंज नहीं करते हैं। उसी तरह से एटम के इर्द गिर्द, न्यूक्लियस के इर्द गिर्द जो इलेक्ट्रॉन्स घूम रहे हैं वो भी अपने आप अपना पाथ चेंज नहीं करते हैं। हाँ, ये बात अलग है कि सन से अर्थ से कुछ पर्सन्स निकल के मून पे जा सकते हैं, मार्स पे जा सकते हैं, right? You know the moon mission, Mars mission, like that one, right? But it is a different case. They are not changing their path. समझ में आ रहा है?
While the planets revolve around it.
Children, are you getting this one?
Yes, ma'am. Yes,
Now
ma'am.
watch it.
You noticed that the planets always revolve in fixed paths? We never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center, and the electrons are like planets which revolve in fixed, defined orbitals. These electron orbitals are referred to as shells or energy levels. Now, the name energy levels gets us to an important concept. Niels Bohr suggested that the electrons revolving in these orbitals do not radiate energy. This is justified when we use the term energy levels, because it indicates that each shell has got a defined energy level. That means when the electrons revolve in these shells, they do not liberate any form of energy. And how do we name these shells to indicate their position? It's simple. Beginning from the one near the nucleus, we name them as the K shell, L shell, M shell, N shell, and so on. Yes, K, L, M, N, and so on. And what if we want to number them? In that case, we use the letter N in lowercase and write them as N equals 1, N equals 2, N equals 3, and so on, beginning from the one next to the nucleus.
Now see, in this case here, how Bohr has been defined the energy levels. This is the center. At the center, there is a presence of the nucleus. And around this nucleus, this is the first one energy level. This is the second one energy level. This is the third one energy level. And this is nothing but the fourth one energy level. These energy shells or these energy levels are also known as a discrete orbits or the discrete orbitals. And these are also named as the shells, energy shells or the energy levels. Each energy level, it is denoted by using a typical kind of the symbol, like as K, L, M, N, O, P, Q, like these one, right? Now in the first shell, it is to be denoted by the number that is small n, which is equal to 1, right? Small n, it is equal to 2, that is the L shell. Small n is equal to 3, that is the M shell. Small n is equal to 4, that is the N shell. If suppose small n is equal to 5, then it is a O shell. Whenever it is the n is equal to 6, then it is a p shell. When n is equal to 7, then it is a kind of the q shell. Now each shell, it is having the definite number of the electron within each one. Actually, the electrons present in these shells can be given by the formula 2n square. 2n square means 2 multiplied by n multiplied by n. That is nothing but the 2n square. Suppose n is having the value is equal to the 1. Then 2 into 1 square. How much it is? Yes, what is the answer for that? 2 into 1 square.
2.
2 into 1 square. Is
2.
it 4?
4.
Is it 4?
2.
2. 1 का स्क्वायर
4.
1 ही होता है बेटा. 1 का स्क्वायर 1 ही होता है. 2 into 1 का स्क्वायर यानी कि 2 into 1 which is equal to 2. फर्स्ट शेल में कितने इलेक्ट्रॉन है? सिर्फ 2 इलेक्ट्रॉन मैक्सिमम ऑक्यूपाई हो सकते हैं. n is equal to 2. How many number of electrons? 2 into 2 square. कितना आ जाएगा आंसर बोलो?
8.
2 into 2 square 8. Very good. Means in second shell, maximum 8 electrons can be accommodated. What is n is equal to 3? How many electrons does the
27.
huh?
18.
18. Very good. 2 into 3 का square. 3 का square है 9. 9 2 जा 18. n is equal to 4 में कितने electrons accommodate हो गए?
32.
Very good. 32. 2 into 4 square. That is 4 का square है 16. 16 multiplied by 2 is equal to 32. Have you got the simple mathematics? समझ में आया? These
Yes,
are
ma'am.
the maximum number of electrons. Those are present within this shell. Have you followed this one? समझ में आया ना सबको? मैं नोट्स लिख के दूंगी आपको, पहले समझ के ले लो. ठीक है? First of all, you have to understand and then I will give you the notes. समझ में आया क्या?
Yes, ma'am.
Very good. Now, watch the video carefully.
So we can name them alphabetically or we can even number them. With all these theories and points known, do we now know the structure of a typical atom completely? The nucleus contains positive protons and the electrons revolving around in fixed orbitals. Is that how an atom is structured? Not really. We still have one more subatomic particle left. And what and where could it be? Let's find that out. It was around the year 1932 when a famous English physicist, Sir James Chadwick, found the third subatomic particle. He found that the particle had a mass almost equivalent to that of the proton. And what about its charge? Astonishingly, it had no charge. Yes, the particle was neutral. The particle was later named as neutron, denoted by the letter N. Thus, now we have the complete design of an atom. In the center lies the nucleus, having positively charged protons and neutral neutrons, while the negatively charged electrons revolve in fixed orbitals around the nucleus. But how exactly are the electrons distributed in the respective orbitals? Is there a way to find out the maximum number of electrons that one orbital can contain? Or is it that the electrons are randomly scattered in the orbitals? Let's find out the answers to these questions in our upcoming video.
Children, have you watched the video carefully? Have you got the structure of the atom which is given by the Bohr? Bolo?
Yes, ma'am.
Yes,
Very
ma'am.
good. Now, I'm going to give you the notes for this one. First of all, I have told you that what is meant by the discrete. Meaning of the discrete orbits means having a definite amount of the energy. Actually, in the last class, we have ended the class by giving the postulates of the Rutherford's atomic model. Right? What is the last line in the yesterday's class? Yes. Read it out. Yesterday's class, I have given you the notes. What is the last line within the note? Anybody? Yes, children? कल मैंने जो आपको लिख के दिया था उसकी लास्ट लाइन क्या थी? अरे कोई भी लिख के नहीं ले रहा है क्या?
Electrons are
Electrons
revolving
are
around
moving around nucleus in circular path.
path known as orbit.
हाँ, यानी कि मैंने रुदरफोर्ड का मॉडल आपको दिया था, राइट? नाउ वी हैव टू डिस्कस रिगार्डिंग द advantages of advantages of advantages advantage of Rutherford model of atom. Because in examination you have been asked what are the merits and demerits. Merits means the advantages of the Rutherford model of the atom. First one, Rutherford's model of atom is based on or is experimentally based. Is experimentally based. Is experimentally based on. It is based on the experiment. Experimentally based. Right? Second thing, Rutherford has been given. Rutherford given the term nucleus and orbit, right? And orbit. समझ में आया? उसने ये दिया. These are the advantages, right? Another one advantage, Rutherford exactly located the position of proton and electrons. Proton and electrons. Have you followed this one? These are the advantages of the Rutherford model of the atom. Now we have to discuss regarding disadvantages of Rutherford's model of atom. Rutherford's model of atom, right? What are the disadvantages? The first one and very much higher drawback is that Rutherford fails to explain stability of structure of atom. Now how? As electrons are charged particles, they during their revolution in circular orbit, they are accelerated and start to emit energy in the form of radiations. They are accelerated. They start to emit energy in the form of the radiation, right? They start to emit the energy in the form of the radiation. Now, hence, they start to emit the energy in the form of radiation. Hence, they come closer to nucleus. They come closer to nucleus and settle down on nucleus which leads, because of which atomic structure is collapsed. Right? Atomic structure is collapsed. Now, for correcting Rutherford model of atom, Bohr has been put forwarded its model of atom. His model of atom on the basis of following assumptions. Right? Which are the assumptions are there? Which are the assumptions? First, means these are known as the postulates of Bohr's model of atom. Bohr's model of atom. Bohr's model of atom. Postulates. Of Bohr's model of atom. First one postulate. Electrons are revolving in discrete circular orbit in an atom. Discrete circular orbit in an atom. These orbits are known as energy shells or energy levels. Energy shells or energy levels. Second postulate. While revolving in energy shells, electrons are not emitting the energy associated with them. Are not emitting energy associated with them. Right? With them. Next one. Third one. These energy shells are denoted by letters like as K, L, M, N, O, P, etc. While they are denoted in the form of numbers like n, which is equal to 1, 2, 3, 4, etc. समझ में आया? Energy of these orbitals of these shells can be given as K is smaller than M, is smaller than N, is smaller than O, is smaller than P, is smaller than Q, etc. राइट? समझ में आया ये?
Yes, ma'am.
Maximum number of electrons in the shells can be given by the formula 2n square. ये 2n square है, 2n square, 2 थोड़ा सा n के ऊपर, where n is equal to 1, 2, 3, 4, like this. So, right? 1, 2, 3, 4, like this, so on. I followed this one. समझ में आया?
Yes,
अब
ma'am.
हम अगले क्लास में डिस्ट्रीब्यूशन ऑफ इलेक्ट्रॉन देखेंगे. इसमें कुछ क्वेरी है किसी को? Anybody is having the query? Have you written all these things? Shall I stop here?
Yes, ma'am.
Yes,
Okay. Now children listen. See here. You have to remember all these things. Okay. We will move or we will meet in the next meeting now. Any query from anybody?
No.
Okay.
No, no.
Okay, beta. We will stop. Bye.
Bye, ma'am.
Bye bye.